All right, Math 2, here we go. We've got lesson 7.1.4, more geometric proofs. So this one, we're just going to show some of our two-column proofs and show it when we're trying to prove things about quadrilaterals using the triangles. I'm going to have to remember to get up in the middle of this to walk around so that my light doesn't shut off, because this will take a little bit. Okay, so it's really important when you're doing a proof to have an idea of where you're going before you actually start writing down all the statements and reasons. Like if you want to travel somewhere, you don't just hop in your car and start driving. You figure out how to get there first, right? So that's what we're going to do. We're going to figure out how to get there first. We've got a rhombus here. What we're going to prove about rhombuses is that when you have a diagonal, it cuts these angles in half every single time. We're going to prove that, of course, with triangles. So I've got two triangles here. What I want to do is I want to prove that these two triangles are the same. And then if those two triangles are the same, then that means that these two angles are the same because they're corresponding angles. That's my goal. Well, I know that these are rhombuses, so I know that I'm going to be able to show that all these sides are congruent. So I'm going to really want to be able to show that this side's congruent to this side and this side's congruent to this side. Now I know all the sides are congruent, so that's not going to be too hard, because then I'm going to be able to prove with these two triangles congruent that these two angles are congruent. But before I do that, I still need one more thing to prove that these two big triangles are congruent, and I can use the reflexive property here. So it looks like I got side, side, side here. So once I've proven the triangle is congruent, I'm going to show that these angles here are the same, which means that they've been bisected. That's the goal. Let's do it. All right, so we start with our statements and our reasons. Our first statement is always going to be our given. So we were told that triangle, or that quadrilateral ABCD is a rhombus. And that means that it is given. Okay, now in a rhombus, all the sides are congruent. So I can pick any two sides and say they're congruent. So I'm going to pick this side here, AB, and this side here, BC, and say they're congruent. So step 2, I'm going to say that AB is congruent to BC. And at the same time, I'm going to say that AD and DC are congruent. I know that because this statement said it was a rhombus. Therefore, this next statement, I can say those sides are congruent because that's what a rhombus is. It has all congruent sides. So we'll just call this definition of a rhombus. All right, I've got two things that are congruent so far. Remember, we always need 3. So I'll use my reflexive property now. We said we were going to use the reflexive property right there. So I'm going to say that BD is congruent to itself. So BD from one triangle is congruent to BD from the other triangle. So this is the reflexive property. And now I know that these two triangles are congruent. So I'm going to say that BAD is congruent to BCD. So triangle BAD is congruent to triangle BCD. And we said this was going to be because of side, side, side. All right, next, I can now show that this angle here is congruent to that angle there. Why? Because this angle B from this triangle and this angle B from the other triangle, they're both the first letters, meaning they're both congruent to each other. So I can say, step 5, that angle ABD is congruent to angle CBD. And the reason? CPCTC. Corresponding parts of congruent triangles are congruent. So if you prove the triangle is congruent, the parts that weren't proven congruent earlier are now proven congruent. Like we can use CPCTC to show that angle A is congruent to angle C if we wanted to. All right, so remember CPCTC always comes after you have just proven that the two triangles are congruent. Next one. We know that angle E is congruent to angle G. And we're going to draw a line that bisects F. So I'm going to draw a line that bisects it. That means this is a bisector. I'm going to call this H. So I'm going to add to this given. We drew a line, and FH bisects angle F. So this segment here is bisecting that angle up there. Now we're going to try to prove that we're looking at an isosceles triangle. Right now we've got two base angles down here that are the same. But with an isosceles triangle, the definition of isosceles is that two sides are the same. So I'm going to try to prove that this side and this side are the same. How am I going to do it? Again, we're going to prove that these two triangles are congruent, and then use CPCTC to show that these two sides are congruent. So let's plan it out. Well, I've got reflexive property again right here. So this triangle and this triangle. I've got this angle. There's two things. I need three things. And the last thing is that FH is bisecting F. So this angle here must be congruent to this angle here because we decided to make a bisector right there. And now the two triangles are congruent by angle, angle, side. So I can show the triangles are congruent. Then I can use CPCTC to show that these two sides are congruent. And then that proves it's an isosceles triangle because an isosceles triangle has two congruent sides. Let's do it. I got my plan. I'm ready to do it. Statements and reasons. All right. Statement number one is always our given. Angle E is congruent to angle G. And we also added this extra line in there. We said that FH bisects angle F. And those were our givens. We have one congruent part in there. We need two more, and these are the two that we planned on. So let's do those. Step two, I'm going to say that FH is congruent to FH. And of course, that's the reflexive property. I've got two parts proven congruent. I need a third part. The third part is going to be up here. EFH is congruent to GFH. Angle EFH is congruent to angle GFH. And the reason was because of this statement here, they were bisecting. The angles being cut in half. So we can say here that this is the definition of a bisector. A bisector cuts something into two congruent parts. All right, I've got my three things. I can now say that this triangle and this triangle are the same, or congruent to each other. So I'm going to say that triangle EFH is congruent to triangle GFH. And remember we said that this was angle, angle, side. Remember, angle, angle, side is when the side is not included, meaning it's not directly in between the angles. It's over here instead of between the angles. So this is angle, angle, side, not angle, side, angle. Okay, so once we've proven the triangle is congruent, remember the next step is CPCTC. And I'm going to prove with CPCTC that these two sides of the bigger triangle are congruent. So step 5, I'm going to say that EF is congruent to FG by CPCTC. Okay, and now what am I looking at? I'm looking at an isosceles triangle because it's got two congruent sides. So my last step, I can now say that that big triangle, EFG, is isosceles? Just by the definition of isosceles. Isosceles means we have two congruent sides, and we just proved we have two congruent sides in the previous step. So this is definition of isosceles. Sweet. Let me pause here so I can move around so the light doesn't turn off on us. Just a second. All right, we're good for another few minutes. All right, so next we're going to prove that we're not going to prove. We know that HIJK is a rectangle. So if it's a rectangle is a quadrilateral with 4 right angles, where all the angles are congruent. So all those angles are congruent, they're all right angles. And we want to prove that HJ is congruent to KI. Those are the diagonals. I want to prove that this diagonal over here and this diagonal over here, KI, that those two things are congruent to each other. Well, so I'm looking at two different triangles. I'm going to look at this triangle over here, triangle HKJ, and I want to prove that it's the same as this triangle here, KIJ. And then I'm hoping that this part from this triangle will match up to this part from this triangle. So what are we going to do for this one? Well, we do know that a rectangle is also a parallelogram. So there's a couple things that we could do with that. So we know that a parallelogram, the opposite sides are parallel. We can also prove the opposite sides are parallel because here we've got we've got the same side interior angles. So this angle here and this angle here, they're same side interior angles and they're supplementary. They add up to 180. That proves these lines are parallel. I know this line is parallel to this one because of 90 and 90 makes 180. And so that means these two lines are never going to cross each other. We could do it the other direction as well. And we could use like alternate interior angles. We could do a whole bunch of other stuff. We're going to just go ahead and use this side here is congruent to this side here because in a parallelogram, the opposite sides are congruent. Okay, remember we're talking about this triangle, this one over here, and this triangle over here. Okay, they share a part. They share this bottom part, so that's reflexive for those two triangles. And then this triangle over here has a 90-degree angle. And then this triangle over here has a 90-degree angle. So what do we have? This triangle, side, angle, side. This triangle over here, side, angle, side. So we can prove the two triangles are congruent by side, angle, side. And then by CPCTC, IK from this triangle is congruent to HJ from that triangle right there. That's our goal. All right, so what are we going to start with? We're going to start with our given. So our first statement. I can't spell statement. First statement is our given. HIJK is a rectangle. That's given. We also know that HIJK is a parallelogram. The reason that I know that is that all rectangles are parallelograms. And now, what I've been trying to get to is now I know that HK and IJ are congruent. because opposite sides of parallelograms are congruent. I wish parallelograms was a smaller world. That's a lot to write. Are congruent. All right, so we got all that. So I got one thing. I got this one marked and this one marked. I'm going to say next that angle K and angle J are right angles. And that's definition of a rectangle. So with definition of a rectangle, you can say that they're right angles, or you could have just said that angle K is congruent to angle J. You could have done either one of those. You can either say that the definition of a rectangle is that it has 4 right angles, quadrilateral 4 right angles, or you can say it's a quadrilateral with 4 congruent angles, and it's basically saying the same thing. So angle K is congruent to angle J. So there's my second one. These are both 90-degree angles, and they're congruent to each other. I need a third thing. The third thing is KJ is congruent to KJ. Reflexive property. Okay, so I've proven 3 things about these triangles. That we have side, angle, side over here. Then on this triangle on this side, we've got side, angle, side. So those 2 triangles are congruent. So I'm going to write step 6, triangle HKJ is congruent to triangle IJK. By side, angle, side. And finally, I can now say that HJ is congruent to KI. Now notice up here, H and J is the first and last letter. I and K is the first and last letter. And that's what I've got here, H, J, and K and I. So the reason why we can say that is CPCTC. So now we know that when we have a rectangle, the diagonals are always going to be congruent to each other every single time. All right, last problem. This one's going to take a little while. I almost feel like skipping it. Anyways, turn the trapezoid into a triangle. Okay, sounds good. We'll just make these keep going up. There we go. Let's put A at the top up here. What kind of triangle is it? Well, we said on the back side that if the base angles are the same, then that's isosceles. So AHG is an isosceles triangle. So we started off with the trapezoid with 2 base angles that are the same, and we just kind of explored and made a bigger shape out of it. It looks like, trapezoids just look like triangles with the top cut off, right? So that's what this kind of is. Okay, what may be true about this trapezoid? Well, since we have an isosceles triangle here, that might mean that EH and FG are the same. So we think that EH is congruent to FG. That would make this an isosceles trapezoid. All right, so now we got to prove it. So I'm going to start by doing my statements and my reasons. Let's do our given. We know that angle H and angle G are congruent. And we know that EF is parallel to HG. That was given to me. All right, I've actually got two isosceles triangles, and I'm going to prove it. So I know that the big one's isosceles. I'm going to prove the small one's isosceles now. I'm going to show that this angle here is the same thing as that one, and this angle here is the same thing as that one. Okay, so that's what I'm doing right now. So step 2, angle AEF is congruent to angle AFG. AEF is congruent to angle H. Gosh, what am I doing? And then this angle over here, AFE, is congruent to angle G. And our reason, those are corresponding angles. We got parallel lines, corresponding angles are congruent. All right, step 3. I now know that I've got two sets of isosceles triangles. I can say that triangle AEF and the big triangle AHG are isosceles. How do I know that? Because they got the same base angles. So if the base angles are congruent, we just proved on that previous page that the sides are going to be congruent too. So the base angles of isosceles triangles are congruent. Okay, now that I know that they're isosceles, this top one being isosceles proves to me that this side is congruent to this side because it's isosceles. So I'm going to say step 4, AE is congruent to AF. And I'm just going to say equals. I'm going to kind of play it loose on this one so I don't have to do extra steps, kind of like your book does. The other thing that I can say is since this big one's a isosceles triangle as well, I can say that AH is equal to AG. Okay, just a second. I'm going to move around so that the lights don't turn off on us. All right, we're going to make it through without turning off the lights. So that's the definition of isosceles. Okay, now I'm going to do something a little crazy here. I'm going to say that this whole thing of AH, that it's actually equal to two little parts. It's made up of AE and EH. So the big part AH is made up of two parts, AE and EH. So is equal to AE plus EH. Now remember, we're trying to show that EH and FG are the same sides. So I'm going to get there in a second. So the other thing I'm also going to say is that AG, this whole side over here, is equal to, just a second, my ear itches. Where was I at? Is equal to AF plus FG. All right, and there's a reason for that. That reason happens to be segment addition. I'm just adding two segments together to make a larger segment. Okay, so really what I want to do at this point, to prove that these two are the same, I just said that this one and this one, well, I know that these small parts and these small and this bigger part's the same. I'm going to try to now show that these two parts are the same using these equations that I've done here. So I'm going to be substituting some things. So here's what we're going to do. Trying to think of the best way to explain this. Okay, so you see how we've got this equation here, AH equals HG? Well, what I can do is instead of writing AH equals EA plus EH. So I'm going to plug this into AH instead. Then over here, I'm going to plug this into this one instead. So that new equation, AH becomes AE plus EH equals AF plus FG. Okay, and we just substituted. We're almost done. Okay, now what I really want is for EH, this one, to be congruent to FG. I'm going to now say that this one right here, AF, instead of AF is the same thing as AE. So I'm going to take this one, this is really getting a little crazy, I'm going to take this one and plug it in right here. So step 7, I'm going to say that AE plus EH equals, instead of AF, I'm going to plug in AE because AE is equal to AF. So I've got AE here. All right, so rewind that if you kind of got lost of what I did. I'm substituting a lot of stuff around. My goal is to get these two by themselves. And look what I've done here. AE and AE, I can subtract them from both sides in a second here. So let's see, 7, that was substitution. And my last step, step number 8, I'm going to subtract AE from both sides. And what am I left with? EH is equal to FG, which means they're congruent to each other. We just use subtraction. Because it's okay to subtract the same amount from both sides. So I subtract AE and AE from both sides. And so we have finally proven that if the base angles of a trapezoid are the same, then it's an isosceles trapezoid. So isosceles trapezoids have base angles that are the same. That was super fun. All right, see you guys later. Have a good weekend. Bye-bye.